Science Beetle.
Students, I'm going to go ahead and make this video again. One of our viewers had asked me to update the video, so I'm updating the video for the student who had asked, and so here it is. I'm going to go ahead and do that. Initially, when I had set out this video, I had asked the first question up here at the very top. What is the wavelength of a wave of light with a known frequency of 3.45 to the 5th hertz? And so I provided the answer in that original video. So I decided to go ahead and redo the video totally and add a second question here for us. And so the second question here is this one here. Determine the energy of this wave as well. So we're going to go ahead and go through the entire process, identify the wavelength, and then once we get that information, we'll go ahead and calculate the energy as well. So let's go ahead and get started here. And I've already got a calculator here off to the right. We'll bring that in when we need it. If we look at the information provided in the first question, we see that we are asking for the wavelength. So what I want to go ahead and do here this go around is identify the givens and the unknowns. So what is given to me here is that they want us to find the wavelength, but in this case, we don't know what the wavelength is. We are also provided information about the frequency. So the frequency is given here, and notice the unit of hertz. So we're going to go ahead and write frequency down as well. So here frequency is equal to 3.45 times 10 to the 5th hertz. And so what we want to do now is remember the equations that we've got here. There were two general equations when we're dealing with waves or electromagnetic waves, and that is the speed of light equation, which is c is equal to the wavelength times the frequency. And then the other equation is going to be E, which is the energy, is equal to Planck's constant times the frequency. Keep in mind that C and H here, Planck's constant, these are constants for us. And so for C here, it's a constant, and that is 3.0 times 10 to the 8 meters per second. And H is 6.626 times 10 to the negative 34. And the units here are meters squared, kilograms in the numerator, per second. And so those are the units there that we've got. And so when we do the calculation here, we're going to use the top equation. So since we now have the speed of light, we can take this information here, plug it in, take the frequency, plug it in, and so we can rewrite the equation, this top one, for the wavelength. And so let's go ahead and do that. So here we will use the speed of light equation. So here we're going to get c is equal to the wavelength times the frequency. Now we want to isolate the wavelength, so that means we've got to get this frequency out of the right side and move it over to the left. The way we do that is do the opposite operation. Since the frequency is being multiplied by the wavelength, we're going to go ahead and divide frequency on both sides. When we do this, then we're able to cancel the unit on the right-hand side, and we're left with the equation that we want. And so that'll be c divided by f is equal to the wavelength. Now this is a little awkward to write only because you got the variable that you want on the right-hand side. I prefer to write it the other way, so this is what I'm going to do. I'm going to go over and rewrite it. I prefer to have the equation like this. The wavelength is equal to the speed of light divided by frequency. So this version of the equation is my preference. However, if you want to use this one, that's perfectly okay. Let's go ahead and substitute the values in now. Speed of light is 3.0 times 10 to the 8 meters per second, and then we're going to divide that by the frequency, which is 3.45 times 10 to the 5th hertz. One special note of hertz is that this unit here can be written several ways. So let me go show you over here on the right-hand side. The hertz here, separate this out. Hertz can be actually written as 1 over s, 1 over seconds. It can also be written as seconds to the negative 1 power. So any of these versions can be used. We just happen to use this one here, but keep in mind that this one here will actually, it actually means 1 over s. So that means that this hertz unit will cancel with the seconds in the numerator portion of the problem. And so when we do that, the hertz units cancels, and that leaves the unit of meters, which is what the wavelength is going to be in. So we'll finish up the math here. And so we're going to need to bring the calculator over. So let's go ahead and do that now. So I've already gone ahead and typed in the information, and you can see here in the problem, we've got 3.0 times 10 to the 8th in the numerator, 3.45 times 10 to the 5th in the denominator, and when you evaluate The answer we get here is 869.565. Let's go ahead and write all that number down. And so I'm going to write it down here at the bottom. So the answer here is 869.565. And let's get rid of this calculator. And so what you can see now is that if we look at the answer, however, you got to keep in mind, you can only report the level of accuracy. So in the original problem that was provided here, we only have 3 significant figures in the coefficient. So that the coefficient is this part right here in the front of this multiplication sign. Since there's only 3, that means I can only report 3 of these digits. The first 3 sig figs is I will report the first one, I'll report the second and the third. And so at this point, I need to go ahead and make an imaginary line here and take a look at this 5. So what we're looking for here is a number that is 5 or greater. And if it is 5 or greater, in this case it is, that means that this 9 gets promoted to a 10, which is going to have an effect on the 6. It'll turn that into a 7. So our final answer here is actually equal to 870 point. We're going to put the decimal at the end so we can have the 3 sig figs. And then the remaining unit in all of this is going to be the unit of meters. And so we will put the unit of meters at the very end. Meters. So this here is the answer for the wavelength. Okay, so that'll answer the first problem of this particular question. So let's go ahead and address now the second part of this problem, and that is to identify the energy of the wave. So in order to do that, we have to use the second equation here with energy. We do need to use Planck's constant, however, we are provided that because it is a constant. You now have, in the original problem, frequency was provided, so all you got to do is take these two numbers, multiply them together. Let's go ahead and create some space here on the screen so we can get things done. So what we're going to do here is we're going to go ahead and zoom things up here. So let's just move things up a little bit here. Overall, now we've got the new equation, and let's go ahead and separate this out. We've got a new line down here, and we've got energy is equal to Planck's constant times the frequency. We have both of these numbers, so all we're going to do is plug them in. Frequency, remember, is up here at the very top, so let's go ahead and put that there, and then Planck's constant's right here, and we'll put that here for H. We'll begin with Planck's constant, so here the energy is equal to 6.626 times 10 to the negative 34 and meters squared, kilograms per second. And we're going to multiply all of this by the frequency, which is 3.45 times 10 to the 5th hertz. Now remember, the hertz can cancel with the seconds down here, so we're going to go ahead and cancel that out right now. Cancel the hertz here and cancel the hertz there. And so what's going to happen here in terms of the units, whenever we have units of meters squared kilogram, this is actually the same thing as saying joules. So we're going to go ahead and report that final answer here. Let's go ahead and bring our calculator back. I'll put it on the screen, and then I'll show you the math, and we'll just multiply things together. So here we've got 6.626 times 10. We're going to raise this to the negative 34. So I'm going to have to put here minus 34. And we're going to take all of this stuff here, multiply this entire thing, times 3.45 times 10. We're going to raise that here to the 5th power. And if you do that, actually the information's already automatically solved. So here's the answer at the very end. So let's go ahead and write that answer here at the very bottom. So that means I'll report this as a 2.29 times 10 to the negative 28, and this is going to be reported as joules. So here is my final answer. Let's get this calculator out of the way. And so you can see now, overall, the two answers that we were after the wavelength. We've attempted and acquired that information. We've also wanted to get the energy of the wave, and so we've already got the energy here. So here's the video. Hope you enjoyed it. Keep watching, keep learning, and we'll see you in the next video.